Okay. Okay, guys, let's continue our discussion. So this place is in the background is Giresun Bulancak. Okay, so my wife is originally from Bulancak. So this is a picture I have taken this summer. Güzel mi arkadaşlar? Bence de güzel. Evet. Okay. So we talked about vectors, span of vectors in R2. Let's talk about span of vectors in R3 as well. Okay. So where is this thing? Okay. So let's take, for example, what is the span of two vectors in R3? For example, if these vectors are multiples of each other, 1, 2, 0, and let's say 2, 4, 6, what is the span? What is the span of these two vectors? What do you think in R3? Any ideas? What is the span of these two vectors in R3? So this will still be a line, right? This will be a line in R3. So 1, 2, 0 and 2, 4, 0, they are in the same direction. Okay, one is twice the first vector. So the direction of the vector is the same for both, only their magnitudes are different. So 1, 2, 0 vector, so it's, suppose it's something like this, okay? So the other vector is also a multiple of this. So if we draw this in the three-dimensional space, it will be something like this, right? So what do I mean? So this is the three-dimensional space, x, y, z directions, okay? And this is the vector. This is the vector 1, 2, 0. So span of these two vectors is a line. So this is the span, okay? So span of these two vectors is a line. If they are not multiples of each other, what could we get? So if we have, for example, 1, 2, 0, and I don't know, 0, 2, 3, what is the span of these two vectors? Now, these two vectors are not multiples of each other, okay? So if you look at the span of these two vectors, so 1, 2, 0, it will be a vector. 0, 2, 3 is another vector. So the span of these two guys will be a plane of these two vectors, okay? So let me show it this way. So this is the x, this is z, this is y, this is x. And the span of these two vectors will be all the vectors in this plane spanned by these two vectors, okay? Let's write more mathematically here. So span of these two vectors, span of 1 to 0 and 0 to 3 is a1 times the first vector 1 to 0 plus a2 times the second vector 0 to 3. So these are the vectors like a1, 2a1 plus a2, 3a2. Okay, so span is the whole set, all the vectors of this form. Span is all vectors of this form. Any questions about this? So all vectors of this form is this blue shaded region, or it's not this so it's the plane, right? So so it's not bounded like these lines, but it's all. So maybe I should draw it maybe better, right? I'm not sure how to draw it. So it's all the vectors in this plane. Okay, so there's of course the other directions as well. So it's really like a plane. Okay, a plane is not a bounded region. So I'm not sure if my picture is good. Any questions, guys? No? Okay, so if we get three vectors in R3, their span can be a line, their span can be a plane, or their span can be the whole space. Okay, there are three, these are three different cases. Okay, let's give some different examples. For example, let's talk about the vector space of matrices. Okay, so in this case, let's look at V to be M2 times 2. What is this? So these are 2 by 2 matrices. Okay, and let's take vectors like this. Our first vector. Now vectors are matrices. Let's take 1 0 0 0, and let's take V2 to be 0 1 0 0, V3 to be 0 0 0, let's write 1 0. Okay, now I put vector signs above. Question, why, for the last example, why the span is not R3? Why the span is not R3? Because so I cannot write every x, y, z in this form, right? So this means, okay, let's talk about the last example a little bit more. So maybe, okay, let's talk here about the last example. So if I take some arbitrary x, y, z, can I always solve this in terms of a1 and a2? So it looks like it won't be possible, because in the right hand side I have only two coefficients, a1 and a2. In the left hand side I have what? I have 3, right? X, y, and z. So it won't be possible. So what is the solution? So you see right away that a1 should be x, a2 should be z over 3. And what about y? So once we look at this, y should be really this is the compatibility condition. So y should be 2x plus 2 over 3 Z. Okay, sorry. Can you see this? Okay, so for example, let's take a vector. For example, let's take a vector such as, I don't know, x should be, say, x is 1, and let's take z to be 3, and let's take y to be 0. So the question is this vector, is this in span? Is this in the span? It's not in the span, right? Because it's in, so if you look at it, you cannot express 103 in this form. Why? Because this means A1 should be 1 and A2 should be 1, right? But now, what is Y? So, but 0, you see, is not equal to 2 plus 2 plus 2, right? No. Okay. I hope you understand this. So what did we show? We showed so the span of these two vectors is not whole of R3 because we found a vector 103 which is not in the span. Okay, so we showed one vector is not in the span. We will see later that to span all of R3 you need at least 3 vectors. Okay, less than 3 vectors cannot span R3. You cannot go every direction you want using just 2 vectors, for example. If you have just one vector, you only move along a line in that direction of that vector. If you have 2 vectors, you can only move along the plane which is the spanned by those 2 vectors. Okay, you cannot move out of the plane. To move in all space, you need at least 3 vectors. And if you go to R4, for example, 4-dimensional space, you will need at least 4 vectors to span R4. Okay? I hope this is clear. Okay, let's write, no, it's not in the span. So span is not whole R3, okay? Let's go back to this example. So now we're working in the vector space of matrices. We took, let's say, 3 vectors. Now, vectors here means really matrices. Vectors in the vector space of matrices are really matrices. So what is the span of these 3 vectors? So span of these 3 vectors, you can see right away that what are they? So span of these 3 vectors are all matrices of this form: A, B, C, and 0. So any matrix of this form can be written as a linear combination of V1, V2, V3. Okay? So for example, 1, 2, let's say 1, 2, 5, 0. This is in the span. But 1, 2, 5, 1 is not in the span. Okay? So why is this true? Because if I take the, so this is really A times V1 plus B times V2 plus C times V3. Okay. So any questions? So this is a theorem, and we did some part of this theorem before. So span of vectors in a vector space is really a subspace of that vector space. So span of let's say the vectors v1, vk is a subspace. In the last lecture, we did this for two vectors. If you remember, if we take two vectors and consider all possible linear combinations, then it is a subspace. Now, this is more general than just two vectors. Take any number of vectors and consider their span. Their span is a vector space. Okay? If you think about this, proof is very easy. I won't do the proof, but if you think about this, this is very trivial. It's a subspace of V. Okay? So this is a theorem. Now let's look at some more examples. For example, we had this vector space, which is P2. So what was P2? This was the vector space of polynomials, right? Polynomials with degree less than or equal to 2. Now let us consider in this vector space two vectors. What are those vectors? The first one is, let's say, t square, and the other one is, let's say, t. Okay, so this is really like, let me write in this way. So this is my v1 vector, this is my v2 vector. Okay, so now the vectors are polynomials because I'm in a polynomial vector space. The vectors are polynomials. So what is the span of these two vectors? So the span of these two vectors, or span of this set S, is all polynomials of the form what? At plus bt squared. All polynomials of this form is in the span. For example, 2t plus t squared is in the span. 4t is in the span. 5t minus t squared is in the span. But 1 plus 2t is not in the span, right? Because to be in the span, the constant term here should be 0. There is no constant term here, okay? You see? So the constant term of the polynomial must be 0 to be in the span. It must be at most second degree, and the constant term must be 0 to be in the span. So let me give an example, another example. So is t squared minus t in the span of I don't know, t squared plus 1 and t minus 1. Maybe yeah, let's look at it this one. What do you think about this? So this means whether we can write t squared minus t as a linear combination. To be in the span means to be a linear combination. So I should have constants a and b such that this equation holds, okay? A and b here are constants. So if I write this, what I get? T squared, in t squared parentheses, I have a, and the constant term is b, right? And no, the t term is b, has coefficient b, and the constants are a minus b. So if you look at the both sides of this equation, so let me close this. So look at here and here. So if these are the same polynomial, then their coefficients should match. What does it mean? This means A should be 1. What about B? B should be minus 1, right? So, and A minus B should be 0. So, are these three equations compatible? If A is 1 and B is minus 1, then is A minus B also 0? Is there a solution for this system? No, thank you. So no solution means, this given polynomial is not in the span of these two polynomials, t squared plus 1 and t minus. No, no solution. Okay, no solution means not in the span. Okay, guys. Let's do one more example. Okay, so I have, let's take these vectors 2, 1, 1. V2 is 1 minus 1 and 3. And let's take V to be 1, 5, 7. 1, 5 minus 7. So the question is this: is V in the span of V1 and V2? Please try to think about this for a minute, okay? Try to think about this for a minute and then we will talk. Okay. Any answers? Let's look at it. So first of all, what does it mean to be in the span? To be in the span means I should have, so I'm really, the question is this: is there a solution? Is there a solution of V equals A V1 plus B V2? Whether I can solve the system for AB. Here A and B are scalars. So this is really the question. I think the answer is yes, John. I think so. So let's look at it. So if we write this, what do I get? So 1, 5, and negative 7. Maybe I should make this a little smaller. So what are these things? So this is A times 2, 1, 1. And what about the second one? B times 1 minus 1 and 3. So what does it mean? It means so I can express this as 2A plus B equals 1 and A minus B equals minus 1 and A plus 3B equals minus 7. Okay, so I can convert this into this form. 2, 1, 1. So this is linear system, so I can always convert it into augmented form and work with this augmented form. Okay. So if I can show that this system has a solution, then I'm done. So what can I do as a first step? The first step is I can really swap these two rows to get a better first row, okay? So I swap row 1 and row 2. Then we get 1 minus 1 minus 1, 2, 1, 1, and 1, 3, and minus 7. A eksi B 5 olmayacak mı? Yanlış yazmışım. Thank you. So this should be minus 5, right? No, 5. Teşekkürler Barış Azar. Okay, so once we have this, oh, there's also 5 somewhere here, right? So this should be 5, yeah. Now it is right. Okay, now what can we do? We can eliminate the second, so I can make these guys to be 0 by using minus 2 row 1 plus row 2 to row 2, and also minus row 1 plus row 3 to row 3. Okay, so in this case, what do we have? We have 1 minus 1, 5, and I get 0 minus 3, and what is this? Minus 9, and I get 0, 2, and minus 12, I guess. Is this right? Bir yerde yanlışlık yaptık değil mi arkadaşlar? Bu cevap yes olacak gibi görüyorum ben. 1, 3, eksi 7. Minus 3 will be... Ah, you're right. But does it change? I'm not sure. Burası 3 mü olacak? Okay, let me do the computation again. Minus 2, minus 9. Oh, this will be 4, right? Okay, now this is correct. Okay, now everything is good. So I can do row 2 over 3 to row 3, row 2, and row 3 over 4 to row 3. If I do this, what do I get? I get 1 minus 1 and 5, and I get 0, 1 minus 3, and I get 0, 1 minus 3. Now finally I can write minus row 2 plus row 3 to row 3. If I do this, what do I get? Let me write it here. I get 1, 0, 0 minus 1, 1, 0, 5 minus 3, and 0. Okay, now what this means is this equation has always a solution. At this point, we can really stop because this last line says 0a plus 0b equals 0, which is always true. And from the second equation, I can solve this for b. Okay, so b is really -3. And once I find -3, I can plug it back to here, and I get a minus b equals 5, which gives a equals what? A equals 5 plus b, which is 2, right? So this system has a solution. The important thing is it has a solution. We're not interested what the solution is. The important point is whether it has a solution or not. So yes, the answer is yes. So the answer to this question is yes. So the answer to this question is also yes. Okay, both questions is yes. Okay, let's do one more question, one more example. Okay, so in this case, we have 3 vectors. 1, 2, 1. 1, 2, no, 1, 0, 2. And the final vector is 1, 1, 0. Okay. What is the question? Okay. Do these vectors span R3? Okay. What does it mean? What does this mean? So the question is really, can I write any vector x, y, z using these 3 vectors? A times v1 plus b times v2 plus c times v3. Can we find ABC such that this equation is satisfied? Let's see it. What does it mean? Let's see it. So this means really, so if you look at the first equation, it means x should be a times the first component of v1 is 1, b times the first component of v2 is 1, and c times the first component of v3 is 1. Y equals a times 2 and 0 times b plus 1 times c, and z equals a plus 2b plus 0c. Okay, so the question is, can I solve this system for ABC in terms of xyz? Okay, so xyz is given, and we're trying to find whether this system can be solved for ABC. So let's write in terms of xyz. This is really the question. Okay, so let's look at it. So if we write this in augmented form, we have 1, 1, 1, and 2, 0, 1, and 1, 2, 0. Here I have x, I have y, I have z. Okay, so is this system consistent or not? So again, we will use row operations, right? So we first try to make these guys 0 by using the first row. So if we do that, what do I get? So minus row 1 plus, no. So minus 2 times row 1 plus row 2 to row 2, and minus row 1 plus row 3 to row 3. So if you do this, we get 1, 0, 0. Then we get 1 minus 2, and this was minus 1, so this is 1. This is 1, this is -1, and this is -1 x. What is this? This is y minus 2x. And what about this? This is z minus x. Okay, so we're done with the first part. Now easy step. So I'm trying to make this guy to be this expression to be 1. So to do that, I can swap these two rows. Okay, swap these two rows, because I already have a 1 there. So if I do row 2 and row 3 swap, let me write this. Please check the computations. Okay, probably I'm doing something wrong here. 0, 1, -1, and z minus x. 0, -2, -1, and y minus 2x. Okay. Okay, now what is the final step? Final step is this. Now I'm trying to make this guy to be 0. So to do that, I write what? I write 2 row 2 plus row 3, row 3 to row 3. If I do that, what do I get? I get 1, 0, 0, 1, 1, 0, and 1, -1, -3, x, z minus x, and y minus 2x. Now what is this? Plus 2 times z minus x. Okay. Is this good? Okay, now what we are interested in is whether this system is consistent, whether there's a solution. We're not interested in what the solution is. Okay, so if you look at it, so this means -3z equals, I'm sorry, -3c equals this thing. So I can always solve this for c, right? By dividing both sides to -3. Okay, let me at least write that part. So the last equation means c equals the whole thing on the right hand side divided by -3. Okay, I can solve this for the last equation for c. Once I find c, I write this c here. So this is minus c, b minus c equals this. So I can solve this second line for b. Once I solve b and c, I can solve the first equation for a. Okay, all those things can be found, which means the answer is yes. So this system is consistent. So the answer is yes. And can you see what could go wrong? What could go wrong so that this system is not consistent? So the thing that could go wrong was if I had something like 0 here, okay? If this was a 0, then this means I have 0 here, line of shape. So the left-hand side is 0, and the right-hand side can be non-zero. In that case, that system is not consistent, okay? But here we don't have that. This is not 0, this is -3, okay? Since it is -3, I can always divide it to -3 to find c. Does this make sense? Okay. Okay, let's look at another example. Again, let's talk about the vector space. Let's choose it to be P2. So polynomials less than or equal to 2. Let's take two vectors, which is t squared plus 2t plus 1, and V2 to be t squared plus 2. Does these two vectors span P2? This is the question. What is P2? P2 is the polynomial space, right? So can I write any polynomial in P2 as a combination of V1 and V2? What do you think? Without solving it, what do you think? Is the answer yes or no? Fatih says no. Nazmi says no. John says no. The answer is no. Let's look at why it is no. So we take any polynomial, right? Any polynomial. So which means I'm taking a polynomial like this, bt plus ct squared. So the question is whether I can find constants a1 times v1 plus a2 times v2. Can we solve this? A1 and A2. Okay, so the answer is no. Why? Because if you look at it, what do we get? So the right hand side is what? So the right hand side is A1 times, so in t squared parentheses, what do I get? So I get A1 plus A2, right? Maybe I write this in full detail, okay? Let's write in full detail. So A1 times what is V1? This is t squared plus 2t plus 1 plus A2 times t squared plus 2. So I get t squared times A1 plus A2. And I get t times 2a1, and then I get constant terms a1 plus a2. Okay, so we're trying to solve this for a1 and a2, which means a1 plus a2 should be c, 2a1 should be b, and a1 plus 2a2 should be a. Okay, so the first one already fixes this, right? So a1 should be b over 2. This from the second equation. And what do we get from the first equation? A2 should be c minus b over 2. Now the last line gives me a condition now. So a1 plus 2a2 is b over 2 plus 2 times c minus b over 2 should be a. So if this condition is satisfied, then that polynomial is in the span. But if this condition is not satisfied, that polynomial is not in the span. Okay, so let's write this more clearly. So what is this? This is really 2c minus b over 2 equal to a. Okay, so for example, let's give numbers which satisfy this. I don't know, let's take a to be 1, b to be 2, and c to be also 1. And the last condition is satisfied, right? 2 minus 1 equals 1, yeah. So which means 1 plus 2t plus t squared is in the span. But let's take a to be, I don't know, again, let's take to be 1, again, b to be 2, and c to be 4. Then what do we get? Then we get 1 plus 2t plus 4t squared is not in the span. Why it is not in the span? Because you see, for these coefficients, this equation is not satisfied, right? Because 2c is 8, b over 2 is 1, so this is 7. 7 is not 1. So this equation is not satisfied, meaning I cannot express this polynomial in this form, okay? I cannot express, which means that I cannot write all the polynomials in P2 using V1 and V2. So the answer is no. Okay, I cannot express all the polynomials in this way. So we will see later that for P2 we need at least 3 vectors, because P2 is a 3-dimensional space. So you need at least 3 vectors to span whole the space. Okay, 2 vectors is not enough to span whole P2. You need at least 3. Okay, 3 or more vectors will span P2. Okay, guys, this is all I want to say for today. Tomorrow we will continue. I hope you understand. Please work on this material until tomorrow, because we will continue from here. Sorry. Şule Koca, ne diyorsun? Neredesin? Ha, nereden el kaldırıyorsun? Evet, buyurun. Şule Koca. Duyamıyorum seni. Pardon, şuradan unmute mi yapacağım? Unmute yapıyorum seni. Olmuyor, unmute olmuyor. Buraya yazabilirsin Şule Hoca. Hocam yoklama. Şimdi yoklamayı arkadaşlar, bir saniye. Yoklamayı nasıl alıyoruz? Bir saniye, bunu bulmam lazım. Bir saniye bakıyorum. Şimdi bölüm başkanı yazdı bana şöyle alacağız diye. Reports'tan evet alacağım arkadaşlar ben yoklamayı. Sorun yok. Bir kelime yazıyorduk diğer derslerde. Ne yazıyordunuz ya? Daha önce bir meeting sketchleri mutlaka topikte dersin adı olsun. Hocam size bir saniye. Tamam, yazın arkadaşlar. İsim, soyisim, numara yazın. Ben öyle olduğunu bilmiyordum. Siz yazın. Dersimiz bitmiştir.